you're with the gas company, and you're working on the liquefied natural gas project. What's your role there?
My role is predominantly education, information to the public, and then also identifying some of the markets we can use natural gas in.
Ah, okay. And so, I guess the question that comes first is just defining what it is. What is natural gas, and why has it come to the fore these days? Things have happened around natural gas. The market, the technology, it's changed in the past, what, 5 years? And now it's worth talking about. Tell us about what's going on with natural gas.
Well, let me start with what natural gas is, or LNG is rather. LNG is nothing more than natural gas cooled down to about minus 260 degrees Fahrenheit. And when you do that, it basically becomes pure methane. So it's a very clean burning fuel. And by putting it in its liquid form, we're able to transport it very economically over long distances. Because basically it collapses 600 cubic feet of gaseous material into 1 cubic foot of liquid material. So we can move it very easily back and forth.
So it has to be refrigerated the whole time, yeah?
It does, and it's put inside of cryogenic containers that are basically big thermoses. So they're sealed up at little to no pressure, and kept insulated during its voyage.
You don't need, yeah, that's interesting. You don't need a big steel container, a big hulking, huge, strong container if you keep the temperature down.
That's right.
There's no pressure.
That's right.
It's all contained.
Yeah. Yeah.
On the other hand, if you lose the refrigeration, what happens?
Well, over a period of time, you're going to have what's called boil off. And the liquid inside of the tank is heating up, and there's a little vapor space, and that pressure increases, and it comes to equilibrium. But at some point, as the liquid continues to heat up and that pressure builds, it's going to release the pressure relief valve, okay? And then you're going to slowly lose some amount of gas. Now, that doesn't happen until it could be 80, 90, 100 days into storing this. So there's a very long period of time. But on the larger ships, what they do is they take that boil-off gas and they refrigerate it, or they liquefy it and they put it back in.
Sure, why lose it?
Or they use it as a fuel gas to actually operate the ship.
Oh, interesting.
So in our case now, we're not going to be using these large ships right away. As we start to bring natural gas in the form of LNG to Hawaii, we're going to use a much smaller logistics model, which is we're going to use 10,000-gallon cryogenic containers, and these are nothing more than a large mobile steel thermos. And if you put LNG inside of one of these containers, it has about a 120-day life between fill and extraction of the product. So you've got a long time to move it back and forth and then place it and use it.
So I want to digress on one of the points you mentioned, and that is it could be used. It could be used, the part that bleeds off, to power the ship.
Mm-hmm.
But ships are usually diesel engines. How does that work? Oh, that sounds great, but how does it work?
Well, not all the ships are able to run on natural gas, but some of them are, and a lot of the newer ones that are being built are being configured to do that. So if it is not used as a fuel gas, it's simply refrigerated and put back into the cargo, so you're not losing it.
Okay, but when it does go to power a ship, I mean, even say in a converted diesel or a modified diesel engine, is it used as a liquid, cold, hundreds of degrees below zero, or is it used as a gas, warm?
It's and that's a good point. There's I think a fundamental misunderstanding there. Natural gas is simply a means to move it from one market to another, and mostly to move it to markets that are physically disconnected from a natural gas pipeline. That's why you do it.
Right.
So it's simply to move the product. Once it arrives at the point of use, in this case it's still on the ship, it's in its gaseous state. So
Right.
the boil off is gaseous,
Right.
and whenever you use natural gas, it's always in a gaseous state. So LNG must be heated up or vaporized in order to be combusted.
Okay, so going a step further with that, so assuming now that the the container, this container you described, refrigerated container, gets to say Hawaii, what happens in Hawaii to get this to actually generate electricity? What has to happen to the gas?
Whoa, you're jumping a little bit ahead of what the gas company is working on right now.
Curiosity drives me.
So let me back up and describe what the
Sure,
gas company is
sure,
working
sure.
on, and that is we're seeking to diversify our fuel supply, specifically our utility gas fuel supply on Oahu. You know, we have one source of supply right now, and that's the naphtha that we purchase from the neighboring refinery. And the price of our utility gas, just like electricity, has continued to increase because both of us are inextricably linked to the price of the imported crude oil. So not only is the price going up, but we have a sole supplier. And we looked at that a few years ago, and we also looked at what's going on with the refineries locally. And we said, you know, we need to look into diversifying this. And when we did, we looked at renewable gas, okay, which we're still pursuing. And we looked at natural gas as being suitable replacements. You know, renewable natural gas, although still progressing, we have a feedstock industry that we still need to develop locally, so that's coming along. But in the short term, natural gas is really the only viable replacement for our naphtha feedstock. And we can't start bringing large tankers immediately because your demand has to roughly equal your supply. Otherwise, you're going to have a whole bunch of this LNG sitting there that's going to start boiling off and you'll never get to use it. So you need to start bringing it in amounts that equal your demand. And when we looked at how to do that, that's when we discovered that it's commonly done throughout the United States right now in these cryogenic shipping containers. There's 113 LNG facilities across the United States, and this has been going on for decades. So at these facilities, a large number of them, I think a little over 50 are peak shaving plants, and these are used to store natural gas for periods of the year that consumption increases dramatically. So in the winter and summer months with heating and air conditioning.
You store it frozen, or as a liquid.
Store it as a liquid. So they'll have a pipeline there, but the pipeline can't meet when demand shoots up enough of the gas demand to drive the power plant to produce electricity. So what they'll do is they'll convert some of that in low periods into LNG. So they'll have a liquefaction facility there. They'll convert it into liquid and store it, and then they'll gasify that LNG when they do need it to produce more power. Now, some of the peaker plants are not co-located with a liquefaction facility, so they'll have to transport from a liquefaction facility to a peaker plant without one for storage in the container.
Right. There's no pipe, so it has to be by a container.
Exactly. So that's where these cryogenic containers come into play. So there's a whole industry that's been functioning like this for decades to move this LNG in this fashion. So when we looked into it, and we found several sites in the mainland where we can buy liquefied natural gas, and we can certainly buy the cryogenic containers, and we can buy the vaporization units we need on this end, okay, to heat the gas back up so it's a gaseous material and we can use it.
I assume you use the gas itself as the fuel to heat it back up.
We do. And when we looked into this model, what we found was that we can buy the natural gas, have it liquefied, put it in a cryogenic container, ground transport to the West Coast, then loaded on a conventional ship of Matson, brought to Hawaii, unloaded, brought to the point of use, and then inserted into the pipeline or used wherever we might use it at a cost that is competitive, if not lower than the current cost of our synthetic natural gas, our utility gas on Oahu. So it's interesting because using the least efficient logistics model to do this, it's still
cheaper than oil.
Than what we're doing now.
Yeah.
Okay. So if that's the case, think about what we can do if we get this to scale. So that's why the gas company is pursuing this. So the first reason is diversification of our own utility gas, and we hope to lower the cost of gas to actually benefit our customers in doing this. So that's step one. Okay.
Okay, well, just a couple of thoughts about that. What's interesting is that you don't have to build a freezing facility. That's very cool. You can buy this stuff already in liquid form. That saves a bundle of money for the construction of what I'm sure would be hundreds of millions to build a facility that will freeze it. Yeah.
Hmm. Yeah, there's several liquefaction facilities and more coming online with so many folks wanting to export natural gas in the United States. So each one of those would need a liquefaction
To other
plant.
countries, it's happening now, isn't it?
It's happening around the world.
Yeah.
And I mean, there's fundamental change in the global structure of natural gas being moved around by LNG to different markets. And I think still in the early stages of that development. But we do not need a liquefaction facility on Oahu if we're shipping in LNG. What we need on this end is nothing more than a big heat exchanger. We need to heat this material back up,
into
and
gas.
that's called a regasifier.
Okay, back to the mainland for a minute, though. So these facilities where liquefaction takes place and where the gas is stored, awaiting demand or for special demand situations, this is explosive, isn't it? I mean, if you put it in at what 1/600th of its original form, then theoretically it could if it returns quickly to its original form, boom. Am I right?
No.
Okay,
No.
so that's what we're here for today.
There's a couple of first. This is a dangerous material, and even our current gas products on Oahu and the neighbor islands are dangerous. Our propane is in a liquid form, right? We hold it at pressure in a steel tank at about 150 pounds per square inch, and it's in its liquid form, and our gaseous material that runs through our pipelines. But there are a lot of compliance requirements that we need to be aware of and in compliance with as a gas company. So going back to the liquefied natural gas question, if it's in a container at little to no pressure, so it's not pressurized, but it's very, very cold, and there's a couple of things that can happen. There could be spillage, and the cryogenic material could cause harm just because it's so cold. And the other thing that can happen, if you have a leak, you have what's basically called a rapid transformation or expansion of this material, and it happens very, very quickly. And in and of itself, it can appear like an explosion, but it's not flammable, if you will. It's just a thermal expansion, but it happens very quickly. And LNG itself, if you were to put a source of ignition in it, would not explode. So you have to
Because it's liquefied.
because it's
It has to be a gas before it will explode.
You have to have the right conditions. You have to have it in gaseous form, and then you have to have between 5 and 15% of the material in a given area in the form of methane, CH4 or natural gas, with the rest being oxygen. And then that gives you your flammability limits, 5 to 15%. And if you have a spark or a source of ignition in that 5 to 15% happening at the same time, then you could have this vapor explosion, this vapor cloud that could occur. But LNG in and of itself is not an explosive material.
So if you had, I'm sort of learning as we go here, but if you had this container, a cryogenic container, that's very cool and keeps it cool and doesn't require a strong membrane, a strong shell to hold it in, lose the refrigeration. In other words, all of a sudden it gets to be room temperature. I think what I hear you saying is there are devices required by the government to let it bleed off so it doesn't go from 1 to 600 immediately. It bleeds off and into the atmosphere so there is no explosion when you lose refrigeration.
Right.
Is this true?
There are a significant number of requirements when you build LNG storage, and there's multiple types of storage. What's called a single containment, a single wall insulated, a double containment, and then there's this full containment where you actually cover the entire thing in a cement barrier. But the point is that, again, there's a lot of compliance requirements here. but there are also a lot of mechanical devices that introduce redundancy into the system. So not only do you have monitoring of temperature and pressure, but you have monitoring inspections of the pressure relief valves, certification of those devices. So there are multiple ways to relieve pressure if there were to be a breach, say in the insulation material, and it started heating up. That would be a process that would take time for the thermal heat transfer to occur, and as it heated up, it would trigger a pressure relief valve and start venting.
Mm-hmm. So, have there been any accidents? I mean, federal regulations with that kind of layering effect sound like they got written because of some incident. Maybe have there been incidents that led to all of that?
I'm not an expert on the safety aspects of this, but we certainly have people at the company that are. But my understanding is that for over 40 years we've had a very safe LNG transfer environment, ocean-going vessels and land-based, and no significant incidents during that time. In the earlier days, and so LNG has been around for a long time, there have been some incidents where there's been some casualties, and then the lessons learned from those are what have guided the development of new compliance requirements. So I think the track record, when you look into it, you can go to numerous sources of information and see that the safety record for natural gas and LNG is exceptional when compared to other fuels and all other alternative sources of energy.
They all have their risks, for sure.
Yes.
Okay, before we get on that ship again, I want to stay on the mainland for a little while, and that is, we've had a revolution in the technology. I guess it's the fracking technology.
Yes.
We've had a revolution in the ability to get it out of the ground in such volume so that the actual price on the world market is much less. Can you educate our viewers as to what's happened to make natural gas so plentiful and so easy to get as it is today?
I mean, looking back 3 or 4 years ago, natural gas was $8, $10, $12 per million British thermal units, which is just how it's measured. And I think today it closed at $2.85 per million British thermal units. And if you were to multiply that by 5.5, that will put it into an equivalent per barrel cost, to do an easy comparison. So if you have, let's say, $3 per million British thermal units, and you're multiplying times 5.5 because there's roughly 5.5 million British thermal units per barrel of oil. So it was 5.5 times 3 is somewhere probably around $16.50, I'm guessing, per barrel of oil, okay, equivalent. So we're looking right now at roughly $16 to $17 per barrel of oil, I mean the energy content equivalent.
As opposed to $80 or whatever, $85, whatever it is right now.
Well, that's what we see trading on the market, but we know in Hawaii we buy a special type of crude oil.
It's even more.
It's even more. It's I think it may be a $10 to $20 premium.
Mm-hmm.
So that's the comparison there between the two sources of energy, and I think that alone explains why we ought to look into this for Hawaii. But what we've seen over the past few years is this fracking, this horizontal directional drilling.
Yeah, tell us how that is. How does that work, and why, and what changes have happened in that technology?
Well, again, you're touching on an expert an area I'm not an expert on, but let me give you my layman's.
Because people in general don't know anything about this.
What this means is basically we've figured out a way to drill down what could be several miles, okay, into some formations that have methane captured within the earth, and once down to the correct depth, we now can horizontally drill. In other words, turn the drill 90 degrees and now drill parallel to the surface of the earth. Okay, and once we do that, we're able to inject into that area a liquid substance. And it's at pressure, and this liquid substance at pressure is what fractures the rock formations, the earth formations around the bored hole. And that in turn releases the methane that's captured within those porous rock formations and allows it to release back up through the bored hole. Okay, so that's kind of
So you're forcing the gas out of the substructure and into that hole.
exactly, exactly. And then it's captured, and there's a number of safety devices that are put in place to not allow the pressurized liquid that's pumped in below to get into water tables and so forth. And
Well, that's one of the questions. You said a substance, there's a substance, pumped down into that pipe. What is the substance? Is it water?
well, water is a part of it, but there's some other chemicals as well. But that's an area that I'm simply not that familiar with. But what I do know is that there's a lot of work being done to make sure that the companies that are engaged in this type of work are reporting the types of chemicals that they are using, and that they're tracked, and that there's new regulations and oversight being developed to make this a more safe practice. But obviously, we've all read about some of the issues that have taken place.
But just to understand, it sounds to me, correct me if I'm off on this, it sounds to me that that the chemicals we worry about are the very chemicals in that substance that goes down the pipe. And we worry about that substance coming up into the water table so that somebody winds up drinking a glass of whatever it is, when it may be toxic. Maybe in order to do the fracking properly, you need to have some kind of chemical that might have a secondary toxic effect.
Well,
Is that what we're talking about?
I'm not sure you need a chemical to do that, number one. And so, I think you probably need to do a little bit more research on that. But
maybe they're improving it now.
Well, there's no doubt improving it. And from what I've read from some of the larger companies, such as Exxon, that are doing this, is that they are now using chemicals, or maybe some of them always have been using chemicals that are not harmful. They're able to do this with just water. So. But again, I don't want to speak on that as an authority. But so there are issues there. I think they're being dealt with in a way that's going to make the industry safer. But so that's what we call the unconventional gas, right? The shale gas, the unconventional gas, which has caused the amount of proven reserves, if you will, to increase substantially. And I think the jury's still out on how much of that can be extracted and how much of that can be extracted at a price point that makes sense for the company doing it. As if natural gas is trading so low, some of these unconventional gas plays might not make sense to actually take the gas out of the ground. But there are other sources of natural gas, Canadian tar sands, other oil plays within the United States.
You mean the gas is in the oil or under the oil or around the oil?
Well, correct, and as part of the extraction process and the refining process, you're going to get more gaseous material out of that. So there's the unconventional gas play in the United States is certainly causing our supply to go up quite a bit. But we see something similar happening globally, and they're not all unconventional gas plays. Some of them are more conventional. What I mean by that is it's actually a gaseous deposit.
So you just drill into it and pull it out.
Exactly.
It comes right out.
Exactly.
Easy.
Yes.
So when you go through this fracking process, it's for a situation where you don't have the conventional gas deposit, and you have to look a little harder. So you use the fracking system to look a little harder.
Right, and what had happened in Texas several years ago was a company that started looking into this, and they were the ones that made the headway in the technology and the process to do this, and they were able to start doing it economically. So that was the big difference. At one time, this type of extraction was very costly, and they were able to figure out how to do it. And I believe the technology focused specifically on the directional drilling, and that was the game changer that now opened up the unconventional gas play.
Yeah. So this is a big deal. Within the last 5 years? Am I right about that? It hasn't been.
It's
a
very
long
recent.
time.
It's very recent, and that's why I say the jury's still a little bit out. If you look at the energy information, the government site and their data, and how much we have in reserves and what they forecast going forward. If you look at what's going on environmentally or from a regulatory standpoint with horizontal directional drilling and fracturing. I don't think we have all of that figured out, but I think what we do know is that the gas supply is increased substantially
Because of this technology.
because of this technology, and increased substantially throughout the world because of other conventional gas plays and new supplies coming online. So we see a global supply of natural gas increasing.
So is the U.S. the biggest? Maybe it's the technology. Maybe it's just a natural resource. Is the U.S. the biggest supplier of natural gas now? I've heard it said that the U.S. is the new Middle East of natural gas, the new Saudi Arabia of natural gas. Is there any truth to that?
There's folks far more knowledgeable than me. I've just done a little reading on this, but I don't know if I'd go that far. I mean, Russia has huge deposits. Australia has
Sure. They get
huge deposits.
in disputes with the pipelines crossing into Eastern Europe. Yeah.
Now, then one of the differences is you've got to be very careful when you start talking like this because. Who has the largest amount of natural gas? Because you really have to break it down into what is proven, and that is I know it's there and I can get it, okay? And then what is probable, okay? Meaning, well, it's there and I think I can get to it, and then one other category is it's possible. Okay, so what are the possible reserves or supplies, and then what are the speculative? So there's actually 4 categories when you break this down, and you've got to be very careful that when somebody says we have, this much, well, is that proven reserves? Is it probable?
Well, I've heard it said that there's 600 years of gas there.
You mean in the United States?
Yeah.
No, what was said was that there was approximately 100 years worth of supply.
100 years.
100 years.
Okay.
And
that's the proven part or the unproven part?
That's all of the parts.
Oh my goodness.
Okay, and that's why I say you have to be very careful. So if you look on the Energy Information Administration's website, you kind of track those numbers. What you see is that the proven part of that breaks down to about 20 years. Okay. And then you get into the possible part, or the probable part of it, and then the possible part of it, okay, and then the speculative part of it. And you add all those up, meaning now we've counted everything, okay, even those things that are maybe really hard to reach, and we've got 100 years. But I wouldn't be discouraged by that because, again, the trends are increasing. So I don't think we have to reach out and try to quantify everything and say we have that much, but what's
maybe
important
more
is,
when we start looking carefully.
there may actually be more, and that's again, the jury is still out. What we do know is that supplies have increased globally, and certainly in the United States, and it's abundant. It's the cleanest fossil fuel there is to burn by a far margin, and
one thing you raise in all of this, Joe, is the world wants natural gas for all those reasons, and the American market is not hesitant, not shy about selling it to pretty much anyone that has a refrigerated container. Bring us your tired, your huddled masses and your cryogenic containers, and we'll fill them up. So I'm thinking that when you say it's 20 years or 100 years, that assumes that we'll sell it as fast as we can find it, or rather, we'll sell it as fast as anybody wants to buy it. And so if the world is it's like, are we sure that it's that or way less when everybody starts pulling it out real quick because they love it?
There are certainly people that are on both sides of the fence. There are companies that want to export and are pursuing that. There's many companies that have applied to the Federal Energy Regulatory Commission to seek approval for exportation of liquefied natural gas, and the reason is that they can get it cheaply in the United States, and they can ship it to markets such as Japan, which, due to its location and the fuels that it competes with, can sell it at a much higher price than what they can sell it for within the United States alone. So their profit margins go up substantially. So that's good because it creates jobs. It helps the United States economy, and it has a number of good things for our country.
Isn't there a, call it a national interest in trying to preserve it? I mean, if we were loaded, for example,
Well,
with oil.
that's the other side of the fence, right?
Please.
So if you're on the other side of the fence and you say, that's all well and good if we've really got this 100 to 600 years worth of supply. Let's sell it. Let's create jobs and switch everything in the country to natural gas. But a few years out, given that we're in the early stages of this growth market, perhaps it makes a bit more sense to truly understand what we do have in terms of reserves and go a little bit slower. If we go fast, and we
Say we, the whole country.
we the whole country, if we go fast and we export, one of the things that can happen is it can increase the prices in the United States, which will make some of those shale plays now more profitable, and they'll start pulling it out of the ground even faster. And then we might find out, well, we don't have quite as much as we thought, okay? And that could actually have the opposite effect, and we could deplete our supplies very quickly and then be back to where we started with, of being wholly dependent on oil, and really be paying quite a bit then. So I think we've got to be careful that we understand how much we have in reserves and take a prudent approach to how much we export, and let's not give it away too fast till we understand what's going on.
Yeah, amen to that. I mean, I worry about that. Everybody seems to be, and the developers would be motivated, as a self-interest, sell it as fast as they can sell it and get as much money in the bank as they can.
That's right, and there's a good lesson to be learned with England and Margaret Thatcher back with the North Sea finds for oil. And they found that, and they used the sale of that fossil fuel to drive up revenues, and they had a windfall for a good deal of time. But they took it out of the ground just as fast as they could. And there's not much left now, and now they're very reliant on getting natural gas from Russia, and it's and oil products from Europe, and it's very expensive. So there's some that say, look, we didn't do that very well. We should have extracted slower. We should have, kept it at home, not sold it all off as a major export product just to boost revenues. So there are some examples I think we can look to as to how we might move forward.
Yeah, it's not forever. It's not forever. It's and it has to be stewarded somehow. Okay, well, so the other thing I wanted to ask you about the mainland is about the pipes themselves. I mean, I don't envision, I can't visualize the whole U.S. of A with all these pipes all over. It can't be that way. So there's got to be, the pipes have to be in strategic locations between the gas fields on the one hand and the, cryogification, is that the right word? The refrigeration facilities on the other hand, or the ports, if they're going overseas. So there can't be that many of them. And so there must be a fair amount of shipment in containers between them, yeah? How does that work?
Well, you're getting out of my area.
Oh,
of
I love to do
expertise here.
that, Joe. It's my favorite thing,
There's a lot of pipelines in the interstate pipelines. There's a massive network of interstate pipelines, certainly from the Henry Hub in Louisiana, with major arteries stretching all the way up to New England. And then down through the southeast United States, certainly along the west coast of the United States. There are some gaps, and of course those pipelines tend to focus on larger population concentrations. But in many parts of the Northeast, when you get outside of Boston, or Hartford, Connecticut, or even New York City, there's a lot of plants up there that don't necessarily have main supply, pipelines reaching all the way up, and that's where you'll see a concentration of some of these peaker plants with liquefied natural gas being moved in these cryogenic containers.
It also makes me wonder about, we started out drilling for oil on land, and then we wound up drilling for oil, your reference to the near England and all that, the North Sea, in the water. What about natural gas? I mean, there must be deposits under the water, just as there are deposits under the land. And so when they run out of, I hate to say this, when they run out of gas on the land, isn't it the next step to look for it under the water?
Well, it might be, but I'm not going to touch that one.
Okay, I just curiosity. It drives me, you know. So here we are now, and we're on the West Coast in say Los Angeles, or I don't know, maybe San Francisco. What is the major port for this to be? Los Angeles.
No, it's in Port of Los Angeles or Port of Long Beach.
Okay, and we got to get it from California to Hawaii. We got to get it on a regular basis, you know, on a predictable basis. Whatever happens, we gotta have a stream of it here if it's going to replace as a bridge fuel, you know, oil. So how do we do that best? Now you mentioned that it could go on a container ship in these cryogenic containers, but at the end of the day, you could save a lot of money if you had a tanker. But the Jones Act gets in the way of the tanker. There was an op-ed piece in April about that.
Correct.
Some guy who was with the Shippers Association.
Yeah.
And I just wonder what it looks like because actually the Jones Act it's an issue in the congressional campaign right now today, and people are going to be voting mandate on that issue on August 11th. It's going to be really interesting. But what are the chances? What are the probabilities that we can get the Jones Act, you know, changed for Hawaii anyway, and allow this tanker to be built?
Well, I think there's a lot of challenges with getting the Jones Act changed. I think there'll be some opposition to that just through
From the Marine Labor Union.
Yeah, and I'm not convinced that that's the approach that we would necessarily need to take, and let me tell you why. There are designs of smaller scale dual fuel. What I mean by that is they could ship propane and they could ship LNG. That are of a scale that's small enough to be suitable to Hawaii, and this would be a 3 to 5 million gallon tanker size, and this is what we see here coming now for our existing products. So it's not necessary to have the 150,000 cubic meter ship that's 3 football fields long. So
Not for little Hawaii.
So
anyway.
let's start with that. We just don't have it. One of those ships would provide enough energy for an entire year. So we just don't need a ship that big. I mean, we truly are a different market. We're located farther away from any major piece of land than anybody else in the world, and so a smaller size tanker would well suit us. And there are designs for that smaller size tanker, and I'll give you a name of one. It's called the Coral Methane. And
you mentioned that the other day.
And this ship is now being used around Norway, and it's a dual fuel ship. Now the designs for such a ship, could be used by a U.S.-based shipping company. And there are U.S.-based shipping companies that I'm sure would love to have the opportunity to build a few of these vessels.
Who would they, aside from Hawaii, who would they service? Because if you're on the mainland U.S., you can get it by land. You don't need to put it in a ship at all.
You mean who would these tankers service?
Yeah.
They would service Hawaii.
That's what it would
They
be
would
for.
be dedicated to Hawaii.
Right.
And you might have several of them running continuously.
Several, does that mean 2, 3, 5?
Well, it means let's go with 2.
Okay.
Okay. And
one this way, one that way.
Exactly. And
what do they take on the way back?
Well, they'd probably be deadheading, as they say.
Oh my goodness.
So
Okay.
there may be a product, but right now let's assume that they're just deadheading. And but going back to how you get around the Jones Act, so one option is you simply build a U.S. ship, and there may be some federal programs that we can leverage to help reduce the cost of that. Okay, so that's one approach, and
You mean to incentivize the shipbuilder? So the ship doesn't, so you can get a discount on building the ship.
That's right. I mean, we know the cost structure in South Korea and China, which are the largest builders of LNG vessels in the world, are significantly less than what it's going to cost to do it in the United States. But we can't build them there and have it be a Jones Act qualified vessel. So we need to look to do that in the United States. So how can we get the cost structure down, a little bit? There may be some federal programs that we can leverage to do that. Now here's some more creative ways that this could happen. There are some older U.S.-built Jones Act qualified. They're maybe flagged differently now, but they could be reflagged. They could be retrofitted, modified to serve the purpose of what we want them to serve now.
So you have a Jones Act ship, you put it under another flag, and you reverse the flagging, so to speak.
Yeah.
And then you modify that ship with modern technology, with container, with a, I guess it'd be a tank.
Well,
a refrigerated tank.
could be a there's two main styles. There's could be a cryogenic tank, which you see these big spherical balls poking out, half of them, and or domes, and
Well, you
then
see it. You can see it from outside the ship.
That's
it's not
right.
just underneath.
That's right. And then there's another one which is basically a large membrane that is within the ship, and it fills up the entire inside of the ship. So, either way, it needs to be refrigerated, right, and insulated. But so that's another approach, is that you can take a previously qualified vessel and maybe once again, purpose it to the United
One of
States.
those old cargo ships. I mean, if you just refit it, it's just fine.
So that's an alternative.
But then it could run on the gas.
And you could make it run on the gas.
Yeah.
And then there's another alternative, and that is that you could build smaller barges. Now, they may not be as big as 3 and 5 million gallons, so you'd need more of them, but there are LNG or there are cryogenic barges that could do this kind of work. That could be built.
How big do the ships? I mean, a C-3 cargo ship out of World War II. One of the, I don't know if that you wouldn't consider that. That's too
I think
old.
that'd be a little
That'd
old.
be a little old, yeah.
Yeah.
But something out of the 50s or the 60s, what have you, that is modified, or barge. How big would it have to be? I mean, what volume? What dimensions? What length of ship are we talking about?
Well, like I said, this coral methane, which we can we can go look at the specifics on, is about 2.5 million gallons, a little over 2 million
How
gallons.
big a ship is that?
I don't want to misstate, but for some reason 173 feet.
Okay, I think that's not that very
comes
big.
to mind.
That's a relatively modest size, actually.
Well, yeah, it's I said it's the same size as what we're bringing in now, so
Yeah.
it's not out of the ordinary. But
Yeah.
so there are a few ways I think you can address the Jones Act that we're looking into.
Yeah. But you don't think there's going to be an actual exemption here or a repeal?
Well, I don't want to say I don't think, but I think there
But you wouldn't be seeking it.
there will be challenges.
Maybe I would, but you
we would not.
That's very politic. of
But
you.
there are other ways to do this too. Now, keep in mind that U.S. gas or other natural gas is abundant in not only Mexico but also in Canada. So we don't have the Jones Act issue there. And if we start thinking, gas secured from North America, mainland United States is wonderful. But at a larger scale, gas secured from friendly countries is quite beneficial as well. And we don't need to worry about the Jones Act in those cases.
Yeah, but you want to have backup, of course, in case.
Right. And of course, what we're
something
doing
happens.
in our early stages of this effort, when we're bringing it in very small scale, and the reason we're bringing it in small scale to start with is for some pipeline maintenance work we have to do later this year. So we will, to be in compliance with pipeline regulations, we need to inspect our pipeline, and there's a section of it we need to remove. And while we do that, we want to make sure we continue to serve our customers. So we're going to have this cryogenic ISO close by that pipeline, and we can gasify it and inject that gas into the pipeline. It's a finished product. It needs no more work. And our customers continue to be served while we're doing a piece of major maintenance on our pipeline.
Cool. By the way, I mean, I'm a gas company customer. Hope you don't hold that against me. And I like gas. But I'm just wondering if the naphtha gas that I guess has been the traditional gas coming into my house would be replaceable by the gas that's coming off the LNG. Would you still need to do naphtha, or would you just use the LNG for all the gas you want to sell?
Well, we would phase it in, but let me go back to one of the comments you made. We have about roughly 1,000 miles of pipeline in the island of Oahu, and that's our utility gas system.
This is for my house.
This is for your house, and in that system, it's a synthetic natural gas. It is mostly methane, CH4, with some hydrogen, carbon dioxide, carbon monoxide, and a few other components, but mostly methane, CH4.
But it comes off the naphtha that you get from the refinery.
So here's
oil
how
refinery.
we make that synthetic natural gas. We draw a liquid petroleum product called naphtha from the refinery. So that's a liquid, right? And we heat it up, combine it with steam. We run it over a catalyst. We also insert some hydrogen into it, and through a series of chemical reactions, we produce CH4 or methane. So we take a liquid naphtha and we turn it into a gaseous methane. Okay, and that's what our customers get. That is our synthetic
Right now today.
natural gas. So the LNG, the natural gas brought to Hawaii in the form of LNG, once gasified, is a one-for-one replacement product with the SNG.
So I don't have to pull the gas
orifice.
structures out of my house.
You don't have to do a thing.
And this stuff will work just fine where the methane went before.
It will work just fine because they're both methane products. That's the point. Yeah.
Yeah, that's great. Good to hear.
Now what we can do over time is, as we use natural gas brought over in the form of LNG for some of our emergency work, we can also start to build small-scale storage. Okay, and use that storage and start slipstreaming some of this natural gas into our pipeline. And what that will allow us to do is to start displacing a portion of the naphtha, okay, with the finished product we're bringing in. And that's where the diversification of feedstock for our utility gas system on Oahu comes into play. So over time, we can start to displacing more and more of that. And that is the slow introduction of natural gas in the form of LNG to Hawaii. So that's the step one, right, is start displacing our naphtha in our utility system.
In the existing system, yeah.
And then we can build from there. From there, we've got a lot of customers that have switched from diesel fuel to our other products right now, which are propane and synthetic natural gas. And they've done that for cost reasons. They've done that for environmental concerns or emissions, and they've switched over to these clean burning fuels.
But how do they do that? They have to throw out the diesel engine, or do they modify the diesel engine, or what? Because diesel is liquid, and here's a gas. Can you use the gas in the same engine? What do you have to do?
Well, in several of the cases, what we've done is we've helped them offset some of the cost of the new capital equipment.
So they have to have new capital equipment.
Yeah.
So this is my big question here, and I've been thinking about this, after your discussion at
Well, not in all
Clean Energy
cases.
Day.
Not in all cases do they need new equipment. But
If I have hundreds of millions. I'm the utility now for a minute. I have hundreds of millions of dollars invested. Maybe it's old investment, but it's still investment in these huge generator systems. And you're coming along with something that's attractive on a price level. And it's attractive in the sense that it's clean burning and so forth, and I can stop using oil. But can I use LNG in my existing generator systems, or do I have to do something? I have to throw them out, replace them in some way, refit them. What do I have to do?
Well, I think that's the electric utilities business. I don't want to get into that too much, but let me just give you a basic understanding. If there is a combustion turbine, meaning it's now operating just like very similarly to a gas turbine.
You mean like the biofuel one out of the new peaking plant?
The biofuel is one, or
The one at
Kala'eloa is another.
Yeah.
Those are combustion turbines. So if you have a combustion turbine, a CT, and you can look on our list throughout Hawaii of the CTs.
Not too many. They're all new. The old ones are not CT.
Well, that's right. The old ones are basically we have steam turbines at most of our facilities now. So there's a couple of things you can do, and if we go back to this kind of phase in of how does natural gas get to Hawaii and how does it benefit? So the first step is gas company focused diversification of fuel supply. And then you can move into some small scale, let's call it fuel switching. This would be diesel to gas, fuel switching, for a number of reasons. And you're still using a cryogenic, containerized logistics model, mind you, with no economies of scale, but still competitive. And
well, hopefully it can only get better.
Well, exactly. Now, we would very much enjoy working with larger users of energy to plan out how we might transition some of the other energy demands we have in Hawaii. But let me give you an idea of what could happen. In some cases, you could just switch out the fuel. So you just fuel switch from a fuel oil or a diesel to a natural gas. So,
In gas form.
in gas form, always in gas form, remember. So once it comes to shore, we might store it in liquefied form because it's efficient to do that. Storing it in gaseous form is very inefficient. We would need to put a tremendous amount of storage in place. But to store it in liquid form and then have it expand to 600 times in gaseous form, it would be delivered to a major user in gaseous form through a gas pipeline, just like we have today. So one of the ways you can do this is to simply switch fuels, okay, from a fuel oil to a natural gas. For equipment that would be a boiler, basically heating water, making
So
steam.
those steam generators you were talking about.
So they all stay there.
That's an easy target because they're heating water into steam. So instead of heating it with oil, you heat it with gas.
It's just a thermal load. We're just heating water. So you can.
You have to change the burners or something. That's all.
Right. So you.
That's probably
it.
the most ridiculous understatement, but okay.
So you can make that change. Now the other change you can make if you have a combustion turbine is you may, and I'm not familiar with the specific equipment, so I'll say you may be able to just change the fueling element. So now you're injecting natural gas into the gas turbine, and it hits its combustion section, and it is at pressure, and there's a source of ignition, and it ignites and it spins the turbine.
What's your time frame on this?
Well, our initial phase, small-scale emergency backup, we hope to have in place this fall. And then after that, we'll start to work with, well, we already are working with our large engineering firm, CH2M Hill, to identify locations for storage, small-scale storage, and then physical location for starting to insert this into our utility gas pipeline. So that may be another 12 to 18 months after that, and then during that time, we certainly welcome any discussions with others to talk about how natural gas could help their needs.
Well, the big question, of course, and we have a few minutes left for this, but not too much time, is the whole transitional plan or vision or strategy, because the state policy has been to go to green, go to renewables. There are renewables out there. Some people feel we haven't moved fast enough to that. Other people think that natural gas is sort of like M&Ms. Such as came out at the clean energy thing, that it was a cheap fuel, but it wasn't ultimately good for you. So, but I like to know how you guys see this evolving. I mean, do you see that at the end of the day we'll have all the renewables we've been planning, or do you see that natural gas will continue for a long time and maybe renewables will be off the table simply because they're too expensive?
Well, Ed, let me start by saying our focus is to hopefully several years down the road have a far more diversified portfolio of fuel supply. And what I mean by that is, right now we import 42 million barrels of crude oil a year and another 4 million in finished petroleum products. And if we attack that pie, we can attack it in the electric generation segment, which is roughly a third. We can attack it certainly in the fleet vehicle and maybe the marine vessel portion of that pie as well, which is another third of that. And there's no doubt some other uses in there as well. So I think reducing that dependence on that 46 million barrels of imported petroleum products is what we ought to be measuring, and we ought to be replacing that with the cleanest burning fossil fuel possible. And if it's the cheapest, then that's another.
People are real concerned about cheap.
That's another.
We got all
added
these
benefit.
expenses we got to pay. The state is being weighted down by all these huge expenses. Mm-hmm. People can't make ends meet. So when you come in with a cheap fuel, everybody likes that. Yeah.
Well, it's that's a benefit. So I think we for those reasons we've got to look at it. But I think our focus ought to be is moving away from fuel oil to the extent we can. Okay, and if we can do that by combining new gas turbine technology with an increasing amount of renewable energy, then I think we've got a winning combination. And one of the things that we read about globally is why renewable energy is slow to be integrated with existing grid systems. Texas has achieved a great deal of success by integrating wind into its grid. Now, Texas is a standalone grid within only the state, so they're able to perhaps do things a bit faster and better than other states in the country. But and again, you know, Hawaii is a standalone state as well. And
Well, we'd like it to be. We'd like all the islands to be connected, and it should be one grid.
But the point is that if we can increase the amount of load following or cycling power that we can generate using natural gas, then we can better accommodate the intermittent solar and wind resources that we have. And we can, you know, with better predictive technology for when they're going to slow down or speed
Make
up,
it firm, make it dispatchable.
and better cycling turbine technology that can match that speed of slowing up and speeding down. Now we're able to balance the grid and maximize the amount of renewable energy we have on it. But, you know, our electric utilities are going to be able to answer, you know, the questions about how much of our installed capacity is cycling and how much is base load. And so I can only share with you what I kind of glean from other states.
Yeah, but I mean,
and other
in terms of the
locations.
vision, this whole process of, you know, sort of transforming the system to include at least backup, you know, of dispatchable, making it more dispatchable, is this concept, this transformation for 20 years, 100 years? Is there a perfect, clean, and renewable future ahead of us? Or do you see the need for natural gas to sort of act as a moderating force, you know, almost like storage, to keep the line clean, you know,
Well,
firm and dispatchable?
That is that is what's holding us back to a great extent right now.
Yes.
Is a cost-effective source of long-term backup power.
Well, thank you, Joe.
You're very welcome,
It's been
Jay.
great to talk to you. Aloha.
Aloha.